All right, so we're going to look at some more examples. We have 4 ways we're going to talk about our function representations. So for each one of these examples, we're going to be given either the verbal description or the equation or the table or the graph. And we are going to figure out all of the remaining representations from that information. So for this example, we're given the verbal description. So let's read it. The zoo charges a $4 admission fee along with a $2 charge for each exhibit you visit. Okay, when I have each or per, that tells me that this is probably my rate. My rate, which is usually the slope, is going to be $2 per exhibit. If I look at my graph, it's already labeled for me, so I know the total cost depends on the number of exhibits I see, right? Total cost is y, that is the dependent variable. The independent variable is the number of exhibits I see. Independent is input. This is my x-axis. So I know that whatever I put in is going to be the number of exhibits I watch. And I have $2 charge for each exhibit. Okay, so I have $2 times each exhibit I attend. That's part of my total fee. I also know that just by walking into that zoo, I'm paying a $4 flat fee. Okay, so my total cost Y is equal to $2 for every exhibit, $2 per exhibit, $2 for each exhibit, that's my rate, plus $4 just for walking in total. All right, and so I now have a verbal description and I have an equation. For my equation, I'm going to choose some inputs and find some outputs that match. I'm going to start at input equals 0. It doesn't make sense for me to see negative exhibits. So logically, I have to at least do 0 exhibits. Maybe I just walk into the zoo and walk around but don't go to any exhibits. And then maybe I choose 1 exhibit or 2 or 3 or 4. You can really choose any x's you want. I always say choose x's that you are willing to use and work with in your equation. If I plug in 0 for x, I get y equals 0 plus 4, which is just 4. If I plug in y for x, I get y equals 2 times 1, that's 2, plus 4 is 6. If I plug in if I plug in x equals 2, I have 2 times 2, that's 4, plus 4 is 8. If my x equals 3, up here it would be 2 times 3, that's 6. 6 plus 4 is 10. And you see a pattern happening here. If I plug in 4, 2 times 4 is 8, plus 4 more is 12. So I now have a table, which really means that I have a number of ordered pairs, right? Because I have an x value and a y value that go together. So I can put in my x and y values right into this graph, and I can say 0 goes to 4, and 1 goes to 6, 2 goes to 8, 3 goes to 10, and 4 goes to 12. And so that is my straight line. So I could anticipate, if I had a bigger graph, I could anticipate how much it would cost me if I wanted to go to 12 exhibits. I also want you to see how we would graph this if we were just using the equation. So I'm just using a separate sheet of paper here. It's the same equation that we came up with before, y equals 2x plus 4, and I just don't have my table here right this minute. I know that this is mx plus b. So I know that my slope is 2. Or if it helps me, because I think of slope as rise over run, I know that's like saying 2 over 1. So I go up 2 and over 1. That's my slope. And I know my b value is 4. B is the y-intercept. It's where I cross the y-axis. So if you're plotting from an equation, start with your y-intercept and put a point right there at 4. And you know your slope is 2, or 2 over 1, so we can be from this point, we can go up 2 over 1. Up 2 over 1, up 2 over 1, and we can keep doing that, and we get a line. And so I just graphed using the equation, but earlier we graphed by using ordered pairs, and whoops, I don't know how I can fit these both on the same thing, but you can see, maybe like that, you can see that it's the same line. It's even the same points that we are using, right? Same exact line, same exact points. So either way is fine. You pick and choose whether you want to go straight from the equation to graphing or whether you want to find ordered pairs. And sometimes it's easier to use ordered pairs to figure out your x and y values in a table if your steps are not just exactly 1. So if you have, and we'll see that with another example. All right. I do recommend you do at least 3 points. You maybe don't have to do 5 points, but do at least 3 so you make sure you're seeing the proper trend. All right. So if we look at example 2, it says that we are given just a graph that has the temperature information. This says temperature in degrees Fahrenheit, and this is number of hours. So that's all I have. I'm going to look at my graph, though, and see what I can see. Okay. I am crossing this y-axis right there at -5. Remember, that's my y-intercept, and I know we write the y-intercept, we call it b. So b equals -5. Okay, I also can find my slope. So I'm going to look for points that are very clearly, obviously, right at the intersection points, right here. I'm not going to choose where I have a line kind of going in between some parts of my grid because that's just silly because I don't know exactly what those numbers are. But if I'm right on the intersection, I know what those numbers are. So I'm choosing these 2 points. To get from here to here, I have to go up, womp, womp. I went up 2, and then I'm going to go over, womp, 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 over 3. I went up 2, and I went over 3. Up 2, that's my rise, over 3. That's my run. This is a positive slope. So I know slope, m, equals 2/3. I went up 2 and over 3 each time. I went up 2 degrees and over 3 hours. See how that is? Up 2 degrees and over 3 hours. All right, so if I know m and b, I can write an equation. Y equals mx plus b. If m is 2/3, then it's 2/3 x plus -5. But I'm not going to write plus -5. I'm just going to say -5 because that's more efficient. All right, I've got my equation. Now I can do my input. So I can get my input because these are all ordered pairs. I know this ordered pair is at 0, -5. So 0 and -5 go together. I can find these points right on my graph. This is 3 and -3. If the graph is a little less clear than I want it to be, I can choose my own x values, my own input values to plug in and solve for algebraically. I'm going to give you my big hint. If your slope has a fraction, choose x values that are multiples of that denominator. All right, we already have 3, so I'm going to choose 6 next because 3 times 2 is 6. That way, if I know that x equals 6, I'm going to say y equals 2/3 times my x that I'm plugging in, 6. I'm going to make 6 over 1, and my equation says -5. I can solve this more easily. So 2 times 6 is 12, and that's over 3 minus 5. 12 divided by 3 is really 4, so this equals 4 minus 5, which equals -1. If I plug in x equals 6, my y value equals -1. If I did that right, then if I look here at my x value is 6 and see where do I hit the graph, look at that. I hit it right at -1. That's what I was expecting. So if I plug in 9 back into the original equation, 2/3 times 9, that's 18/3, that's 6, and 6 minus 5 is 1. And then perhaps I'll choose 12. So 2 times 12 is 24. 24 divided by 3 is 8. And 8 minus 5 is 3. Okay, so I have a graph that they gave me. I was able to write my equation, and I have a table of inputs, and you might have chosen different inputs. If you chose inputs that were not multiples of 3, you just would get fraction answers. That's the reason I chose only multiples of 3. Now I need to describe what's happening. So I have temperature in degrees happening, and the temperature that it is outside depends on how many hours I've been waiting to take the temperature again, right? So I know that for every 2 degrees that I go up, it took me 3 hours. So I'm going to say the temperature is changing. It's going up. The temperature is rising 2 degrees Fahrenheit each 3-hour block, each 3 hours, right? So if it's 6 hours from now, then I expect to be up 4 degrees. And if it's 9 hours from now, then I expect to be up to 1 degree. I'm going to be up 6 degrees higher than what I started at. All right. All right, so example 3, this time we are given an equation and we have to come up with all of the other information. I usually do the verbal description last. So if my equation is y equals x plus 4, I remember y equals mx plus b. And I'm looking, how many x's do I have? I have one x right there. There's an invisible 1 telling me I have one x right there. So I have one x, 1 is my slope, my rate of change. 4 is my y-intercept. So if I want to graph this, I'm going to start by graphing the y-intercept. I'm going to start right there at 4. And then my slope is 1, which is the same as 1 over 1. So I'm going to go up 1 over 1. But notice, on your total cost, on your y-axis, these values go up 2. See that? It's 0 to 2 to 4 to 6. So I need to be careful. If I'm going to go up 1, I'm only going to be halfway, right? Up 1, but over 1 ride. I'm going to go up from 5 to 6, and then over 1 whole ride. I'm going to go up from 6 to 7, so I go over 1 whole ride. So as soon as you're kind of doing halfway stuff, you might feel a little bit nervous about graphing everything. Here's an example of when I might use inputs and outputs from my table. So thinking about this, I have the cost of going to this fair. The total cost is dependent on this x-axis. It's dependent on the number of rides I take. Okay, so I know that my input is the number of rides, and I know that this is my equation, y equals x plus 4. I'm not going to do fewer than 0 rides, right? I'm not going to do a negative number of rides. So I might choose 0. If x is 0, then y is just 4. If x is 1, 1 plus 4 is 5. If x is 2, 2 plus 4 is 6, and so on. If x is 3, 3 plus 4 is 7, and if x is 4, 4 plus 4 is 8. All right, so I have my ordered pairs that I can plug in, so I'm going to go to 1, 5, 2, 6, 3, 7, and I can go to 4, 8, be right there. And I could even choose, why don't I choose 10? What happens if I plug in 10, right? So if x is 10, then y would be 14. I'm just choosing another point that I might use. So 10 all the way up here to 14. And you can see that's still on the same line, and it should be. So there's my line that shows me graphically how much it's going to cost me, depending on the number of rides. So if I want to think about wording that talks about my rides and the amount of money that I'm going to spend, I might say the fair charges $4 just to come in, right? A $4 admission rate. And then each ride costs $1, right? $1 per ride, $1 for each ride. That's going to be my rate. So I know that the fare costs $4 to get in, and then $1 per ride. $1 per ride. And so I'm saying $1 per ride, so I know 1 is my slope or my rate, and I double check, and sure enough, I have 1 as my rate. And $4 is my flat fee. All right, so our last example right here, we are given a table, and so we're going to represent the function in a graph, or an equation, or a verbal description given this table. Okay, so I can see I have restaurant cost. So I have total cost depends on what down here? The number of guests I have. The total cost I spend at the restaurant is going to depend on the number of guests I have. So the first thing I'm going to do if I'm given this table is I'm going to just start plotting. I have 0, 60. But I know that that must be my B value, right? So I know B equals 60, right? And I'm thinking about that equation, y equals mx plus b. I know B is 60 because that's where I'm crossing the y-axis. Then I'm going to plot the rest. I've got 3, 150, 3, 150, and then I've got 6, 240. 6 goes all the way up here to 240, and 9 goes to 330. So if I have 9 guests, it will cost me $330. Okay, so that's the line, that's the graph that I would get. So I've got to come up with my equation. So normally we go wump, 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 and we figure rise over run. But when I look at this, if I go up, I'm not just going up 1, right? 150 to 180, I'm really going up 30. So that's just a little more complicated than I want it to be. I'm actually going to pick 2 of these points, and I'm going to use my slope formula. So remember, the slope formula is m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Second y minus first y all over second x minus first x. So now I have to decide for myself which one of these points is going to be x and which one is, which one of these points is going to be the first point and which is going to be the second point. I'm going to say that's my first point, that's my second point. I'm just defining them. Any 2 points will do. If this is my first point, then this is x sub 1, it's the first x, and this is y sub 1. If this is my second point, this is x sub 2, and this is y sub 2. Okay, so now I can see y sub 2 minus y sub 1 would be 150 minus 60. Y sub 2 minus y sub 1. And x sub 2 minus x sub 1 in the denominator is going to be 3 minus 0. So I get 90 over 3, which is just 30. My slope is 30. This is also my rate of change. 30 is my slope or my rate of change. So I know my b value is 60, and I know my m is 30. So my equation is going to be y equals 30x plus 60. It's a flat rate of $60 for this restaurant, and then it's $30 times x. Look at this, x is the number of guests. So the cost is going to be $30 times the number of guests I have, plus a flat rate of $60 just to be able to use that room. So wording-wise, I might say, to host a party at a local restaurant, you must pay $60 to rent it, and then $30 per guest for the food. So cost is $30 per guest. I'm writing this in a different order. $30 per guest plus $60 to rent the room. Again, $30 per guest, $30 per, or $30 for each guest. That means it's going to be $30 times something. So that's how I get 30x. All right, so you have some homework in math space that you can be working on, and we'll do some more examples next class. Good luck.